Welcome to my channel. Your tutor Mariam is here. It's a 45th video of Introductory Physics 1 and the 7th video I'm going to talk about the laws of motion. That is a 5th subject of Introductory Physics 1. In this video I'm going to solve another example about the net force that applying to the box. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like for more. You ready? Let's get started. Alright, let's see what I got here. I have a box and three forces apply to this box. One in y direction and the other two make an angle with x-axis, right? And then I need to find the net force and acceleration on the box. So the plan here is find the component for each force and then add the x direction together and y direction together. Let me show you what I mean. Let's start with F1. F1 only have one component and this is in y direction, right? So that's going to be my F1. My F2 here, if this is my box, this guy make the angle with x-axis, right? So if I'm going to write down the component, this guy right here gonna be F sine theta, which is in the negative direction of y-axis, and this guy right here gonna be my F cosine theta, right? And this guy gonna be F2. And for F3, I have this box right here is gonna make the angle with 60. This gonna be my F3. So the component of F3 gonna be F3 cosine theta, and this guy gonna be F sine theta, right? I'm gonna call them as theta 2 and theta 3. So this guy gonna be theta 2. So these are theta 2, and this guy gonna be theta 3, which make an angle of theta 3, right? If you don't know how I wrote this component, I made a video of this and I explain everything, and also I solve a couple of examples. I'm gonna put the link below. Feel free to check them out. So now I have a component for all forces in x and y direction. Now I need to add the x direction together and y direction together. Let's do it. So to make it clear again, I'm gonna write down all of the force I have here. So this gonna be my y-axis, this guy gonna be my x-axis. I have F1 in this direction, which is positive. I got F3 sine theta 3. I have another force this way, which comes from F2. So this guy gonna be F2 sine theta 2. I have one component from the same force is gonna be F2 cosine theta 2. I have this guy right here, which is gonna be F3 cosine 3, right? Now let's write down the forces. In x-axis, my Fx gonna be F3 cosine theta 3, which is positive, minus F2 cosine theta 2, right? So my F3 is 4 times cosine 60 minus my F2 is 2 cosine 30. If I do the little math, then my answer gonna be 2 minus 3 squared. And this is my Fx. Let's write down the F in y axis. So my Fy gonna be F1, which is 1 newtons, minus the other two components for F are negative. So this guy gonna be F2 sine theta minus F3 sine theta 3, right? And this guy is 2. So this is gonna be 1 minus f2 is 2 sine 30 minus 4 sine 60. And my answer gonna be minus 2 3 squared. So now I have a net force in x-axis and y-axis, but I need to find the magnitude of force. The magnitude of force is s square of fx square plus fy square, right? So I found fx as 2 minus 3 square root plus minus 3 square root square, right? Now I need to do the little math. So it's gonna be 4 plus 3 minus 4 3 plus 12. So that's gonna be 19 minus 4 square, right? Square root. So this guy gonna be my net force. F is equal to m times a. So I have my a as 19 minus 4 3 square, and my mass is 1 kilograms times a, right? And then my acceleration gonna be the same as force, as I have the mass as 1, and this guy gonna be my net acceleration. Usually in the exam or homeworks you don't have this answer like a square root of 19 minus 4 square root of 3. It's like usually you see the integer number, but the way I look this forces and angles, I ended up with this answer. But I think you got a whole idea. I hope you find this video interesting. If you like my video, hit the like button, and I'll see you in the next video.